Okay, so my name is Jonathan. I'm here with my 4 friends from the University of Toronto Computer Engineering. Wisey's over here helping me with the demo. Michael, David, and Zachary are down in the audience waiting. While we do the presentation, I'd like to invite one of our esteemed judges to come up and fit the Oculus Rift headset for the demo. Yes, please come up right now and fit for the demo while we actually go on and describe our project. So our project is piloting a satellite. So kind of show of hands, how many of you have piloted a satellite before? Okay, you guys with your hands up did the demo before, so that's why. But one of the challenges that NASA presented to us was what would it be like to pilot a satellite? And since not all of us can be Chris Hadfield on the International Space Station, we wanted to give you an opportunity to kind of put yourself as if you were standing on a satellite, clinging onto one of the edges, looking out on Earth as it was orbiting. How do we do this? Now that we're living in a virtual world where everybody has their heads down in their smartphones, we actually also have this thing called the Oculus Rift, which is a virtual reality headset, which one of our esteemed judges is now demoing for you. Using the Unity 3D game engine and this Blender technology to create some models for our satellites, we actually were able to recreate kind of a very rudimentary space simulation. So without further ado, I'd like to go to the demonstration. And here we go. So this is what our judge can see right now. Oh, sorry. Turn your head. Is it working? Okay. All right, so you are on the ISS? The ISS? Oh, this is the ISS. Okay. So you are currently going 7.7 kilometers per second around the Earth. You can see the ISS features around you. If you turn towards the Earth, that green is the orbital path of the ISS. You can see a beautifully rendered model of the Earth spinning around. Hold for 1 second. I'm going to switch you to the Hubble. Hubble's good or no? Kepler. We're going to switch you to the Kepler. So this is the Kepler Observatory. You can see off in the distance there is the moon. You have a different view of the Earth. And for our grand finale, this technically is not a man-made satellite, but it is a satellite in the most technical sense. You are now on the moon. And you can see the green and red trails of the ISS, the Kepler, and the Hubble Observatory as they orbit the Earth. So as you can see, we created a realistic space environment using Unity. We have a custom orbiting algorithm. All of these actions are actually done to scale. So the moon rotates at the correct speed. The satellites rotate at the correct speed. And there are satellite trails that we use so you can actually see where the other satellites are. We think there's a lot of opportunity for this type of technology in museum simulations, education, kind of training. Thank you. Training. For maybe space tourists if they want to get a feel for what it would be like to be out there and orienting themselves and learning about reference points. Thank you. Thank you. And that's mostly it for us. Thank you. I'd like to invite the rest of my team members up for question and answer. Thank you.
I seem to be speaking softly. Anyways, I just wanted to let everyone know that the rendering while I was wearing the headset was very well done, so it looked very, very real. You talked about simulation and being used in simulations. Can you talk to me more about that? Like, what have you thought about in terms of whether this is being done here or in space?
Sure. So, for instance, we could see something like this being deployed in something like the Ontario Science Centre, even an interactive exhibit for kids, young adults, even adults. You can see, even everybody here we've demoed it to so far has gotten a really big kick out of it. You can kind of look at the different features of the satellite. In the future, we might have GUI elements overlaying that say which satellite you're on, how fast it's going. You can look down on the Earth and see individual reference points and maybe do some zooming. So this demo we have here is only for Earth, but you can also have satellites that are orbiting other planets, perhaps in the asteroid belts, and do similar things that you would have in kind of a downstairs. There's the planetarium with the overhead concave display. You can kind of do that here as well with basically $300 worth of technology, and it's very accessible, more so than I believe the planetarium observatorium. So I think for that type of simulation, it would be really great.
Right. Did you think about any other type of interaction with the simulation in terms of other? I mean, you said that they could find out more data on what they were looking at. How would you?
Right. So definitely outside of kind of just educational uses, we think we can also perhaps overlay some weather simulations, like real-time weather mapping on over different parts of the Earth, so you can observe cloud movements or perhaps weather movements. In terms of possibly the virtual reality technology, of course, can be extended to provide actual like training for spacewalks, or if you wanted to virtually perform some sort of technical operation on a space shuttle, like Sandra Bullock was doing in Gravity, you could do it without actually going out there. Any of the other questions?
You told us we were done.
Thank you.